Have you ever stopped to think about the water you drink? That glass of water you just had? It has a secret history, a story that is billions of years old. The water on our planet, Earth, is the same water that has always been here. It has been around for a very, very long time. This means the very same water molecules you swallowed today might have once been sipped by a giant Tyrannosaurus Rex. It could have been part of the vast ocean where the first life began. It is a mind-boggling idea, isn't it? You are connected to all of history through a simple glass of water. This incredible fact is possible because our planet is amazing at recycling. Earth is like a giant closed system, especially when it comes to water. No new water is really being made, and very little ever escapes into space. Instead, the same water just goes around and around in a continuous loop. This process is called the water cycle, and it is one of the most important systems on our entire planet. It's a journey that water has been taking for longer than any living thing has been around to see it. It is a story of travel, transformation, and return, happening all around us, all the time. Think of it like a global travel adventure for every single drop of water. One moment, a water molecule could be floating high above your head in a fluffy white cloud. The next, it could be rushing down a mighty river, heading towards the sea. Later, it might be frozen solid in a glacier at the North Pole or deep underground, waiting to be pumped up from a well. The water in your bottle has seen more of the world than any explorer. It has been in countless places and has taken on many different forms, from a liquid to a gas to a solid, over and over again. This constant movement is what makes life on Earth possible. So how does this incredible journey begin? It all starts with the sun. The sun is like a giant engine in the sky, sending down heat and light to our planet. This energy warms the surface of the Earth, including all the water in our oceans, lakes, rivers, and even the puddles in your street. When water gets warm enough, it changes from a liquid into a gas. This invisible gas is called water vapor. This process of liquid water turning into a gas is called evaporation. It is like the water is making a great escape, rising up into the atmosphere. You can see evaporation happening in your own home. If you leave a wet towel out to dry, the water seems to just disappear, right? It has not actually vanished. It has evaporated into the air. The same thing happens on a much, much bigger scale all over the planet. The sun's heat causes trillions of gallons of water to evaporate from the surface of the ocean every single day. Even plants get in on the action. They release water vapor from their leaves in a process called transpiration. It is like the plants are breathing out water. This water vapor is incredibly light, much lighter than the air around it. Because it is so light, it begins to float upwards, rising higher and higher into the sky. They leave the land and the sea behind, embarking on the next stage of their amazing adventure, far above the ground. As the invisible water vapor rises higher and higher into the atmosphere, things start to get chilly. The air way up high is much colder than it is down on the ground. Think about how it is colder at the top of a mountain than at the bottom. When the warm water vapor hits this cold air, it starts to change again. It can't stay as a gas anymore. This process is called condensation. The water vapor turns back into tiny droplets of liquid water. It is the opposite of evaporation. These droplets are so small and light they can float in the air. They bump into each other and stick together. They gather around microscopic specks of dust, pollen, salt. As more join the group, they form something we can see: a cloud. A cloud is a massive collection of billions of tiny water droplets or ice crystals, cumulus. Big, fluffy, cotton ball clouds, cirrus. Thin, wispy ice crystal clouds very high up, stratus. Flat layers that cover the sky like a blanket. Clouds act as giant floating reservoirs. They transport water from places that have a lot of it, like the ocean, to places that need it more, like dry inland areas. A cloud can only hold so much water. As condensation continues, tiny water droplets inside the cloud bump into each other and combine. They grow larger and heavier. Think of it like a sponge. At first it soaks up water, but eventually it's full and starts to drip. The same thing happens with a cloud. When droplets are too heavy, gravity pulls them down. This is called precipitation. Rain, warm air most common. Snow, very cold air. Droplets freeze into ice crystals near or below 0 degrees Celsius, 32 degrees Fahrenheit. Sleet, raindrops freeze on the way down into tiny ice pellets. Hail, strong updrafts freeze layers into balls of ice during storms. Once water reaches the ground, the journey continues. Some soaks into the earth, becoming groundwater. Other water flows over the surface, runoff. Runoff collects in small streams. Streams flow into larger rivers. Rivers carry water back to lakes or most often the vast ocean. And just like that, the water is back, ready to begin the cycle again. This return journey distributes water across the globe. It provides water plants need to grow. Precipitation is the delivery service of the water cycle, bringing life-giving water from sky to land. The water cycle is a powerful and resilient system that has been working for billions of years. It has shaped our planet, carving canyons and creating vast oceans. But for all its power, it is also a delicate dance. Each step, evaporation, condensation, precipitation, is connected to the others in a perfect balance. But what would happen if that balance were disrupted? What if something changed the rhythm of this ancient dance? This is not just a curious question. It is one of the most important questions for scientists today, as our planet's climate is changing. For example, what if the Earth's temperature gets warmer? A warmer planet means more energy from the sun, which would cause more evaporation. More water vapor in the atmosphere could lead to bigger, more powerful storms and heavier rainfall in some areas, causing floods. At the same time, other parts of the world could become much drier. Human activities can also disrupt the water cycle. Building large cities with lots of concrete and asphalt prevents rainwater from soaking into the ground. Cutting down large forests reduces transpiration, meaning less water vapor is released into the air. Pollution from factories and cars can mix with water vapor in the clouds and fall back to Earth as acid rain. We are a part of this cycle, and our actions have consequences. Understanding the water cycle is not just about learning science facts. It is about understanding how our planet works and how we can live in balance with it. We can find ways to use water more wisely and reduce our impact on the environment. The story of water is our story, and it is up to all of us to ensure its journey continues, keeping our world healthy and alive for generations to come. If you learned something new, hit like and subscribe.